Hi everyone, I've had some questions on the Chapter 10 test. I'm going to answer some questions without doing the problems on the test. I've sent everybody the problems they got wrong if you've already submitted the test, and I would like you to redo the problem. So I have a question on number 12. I'm going to start with that question. I think the question pretty much, it says to use the zero product property to solve it, okay? So I'm going to write a different problem out, and I'm going to say a similar problem, not the same problem as number 12. Similar problem might be something like 3x plus 5 squared equals 0. Okay, I think you know this, but I'm going to be redundant anyway, or just I'm going to simplify it all the way to the point that you're like, oh. So you know that the little 2, when you say to square something, means that you're taking the 3x plus 5 times itself. Okay. This is in factored form, okay? It's a polynomial in factored form. When I write it that way, this is a factor, and so is this. Well, they're the same as each other. What happens when you multiply two numbers times each other and you get an answer that's 0? That means one of these two things has to be 0. So like maybe that's 0. No matter what this is, if I multiply it by 0, I'm going to get an answer of 0. If this one isn't 0, but this one's 0, I'd still get an answer of 0. They're identical inside. So what value for x is going to make one of these factors or sets of parentheses equal to 0? Okay, so if you subtract 5 on both sides and then divide by 3, x, the value of x that would give you an answer of 0 would be a negative 5/3, or a negative 1 2/3, or negative 1.6 repeating. There you go, would look like that. Okay, so really what you're trying to do is figure out what x value would turn the part that's in the parentheses into 0. You are finding x-intercepts. You're finding roots. You're doing the same thing you were doing in Chapter 9, because this is usually a y, and when you change that y value to 0, you're finding an x-intercept. Okay, so that's similar to number 12. If you want to pause it there, look at it, breathe, etc. It's not number 12, but it's a lot like it. Your answer would just be x equals negative 5/3 on that problem. Okay, the next problem that was asked of me, I believe, is number 19. So again, I'll do a problem similar to number 19, but not number 19 itself. Number 19 says a rectangle has an area given by, and then it says area equals. So this is going to be like 19, but not 19 itself. Area equals, and I'm going to say, sorry, I'm picking from problems. Let's say, I think this was one in your book, but okay, let's just say x squared minus 9x plus 14. Okay, so if that's the area of your rectangle, you're saying the area is this. You have to find the width and the length, or the length and the width. You do length times width to get area. So really the question is, what are the factors of this? Because what times what equals x squared minus 9x plus 14? Okay, so in order to factor it, you're asking yourself what two numbers multiply together to make 14, and when you add them together, you get a negative 9. And your two numbers should be a -7 and a -2. So your factors are x minus 7 and x minus 2. So your width or length, it doesn't matter which one's the width or which one's the length. X minus 2, x minus 7. One would be your length and one would be your width. Okay, so basically on number 19, it's just asking you to write it in factored form. One of the factors is your length, one of your factors is the width. Okay, so that's 12 and 19. And then the next section, actually as a whole section asked, was, or I had a lot of questions on 25 to 29. I'm going to tell you that 25 and 26 are similar. 25 and 26, you're just going to factor them. And after you factor them, you are going to solve. So I'm going to do two problems where there is not a number in front of the x squared, meaning the coefficient in front of the x squared is a 1. So I'm going to do a problem like that, and then that should help you with 25 and 26. Okay. So let's say I have this problem. Okay. So let's say you have x squared minus 5x minus 84. And the directions say solve. In order to solve it, you need to factor it. So in order to factor a problem that has a 1 here, or no number that you visually see, you can put an x inside both sets of parentheses. You are finding two numbers that multiply together to equal a -84, and when you, when you add those same two numbers, you're going to get a -5, the number in the middle. Okay, multiply together to give you the last term, add together to give you that middle term. So because 12 times 7 is 84, I'm going to use the numbers 12 and 7. However, when I add them, I need to get a -5, and when I multiply, I need a -84. So it's the 12 that needs to be negative in order to add them together to make -5. So I'll just write x minus 12, x plus 7. That's factored form. So if the directions say to factor your polynomial, these are your factors. X minus 12 is one factor, x plus 7 is the other factor. However, they're not asking us to factor, they're asking us to solve. It's kind of what I just did on the last problem, but x minus 12, x plus 7. What would the x values in these two factors have to be in order to get a product of 0? Okay. Well, what would this x value have to be to turn this into 0? What number take away 12 makes 0? X minus 12 equals 0. What number plus 7 equals 0? Okay, so over here, if you add the 12 to both sides, x equals 12. And on this factor, if you subtract 7 from both sides, x equals -7. So your solutions on this problem are 12 and -7. They are not the same as the numbers you came up with in order to factor them. Okay? These numbers help you write it in factored form. To solve, it's what value of x makes this factor equal to 0. What value of x makes this factor equal to 0. So your solutions, or your x-intercepts, are 12 and -7. That should help you with 25 and 26. 27 and 28 are different. I got too much stuff over here. All right. So now I'm going to show you how to factor when you do have a leading coefficient that's not 1. All right, let's see. I'm going to do, here's a good one. All right, so let's say I have, so this is like 27 and 28. Let's say I have 5x squared. See a 5 there instead of a 1 or nothing? All right, you work this problem differently. You still have to factor it. In order to factor it, you need to find two numbers that multiply together to make negative 10. So you need to multiply this number from the first term, your leading coefficient from the first term, with the last term. Okay, so 5 times negative 2 is a negative 10. You need to find two numbers that multiply together to make negative 10, but when you add them, still the middle, equals negative 9. Right, I feel like I might have confused you on that. So when you have a number in the front, multiply the front times the back. I got negative 10. You find two numbers that multiply together to make negative 10, the product of those front and back, and add together to make the middle. Okay, so what times what is going to make negative 10, and when you add them you get negative 9? Your two numbers should be a negative 10 times 1 and a negative 10 plus 1 to give you those numbers. Okay, you are going to get 4 parts now, 4 different terms. Rewrite the first term, 5x squared. Take the two numbers that you just got, negative 10, put an x on it. Positive 1, put an x on it, and then recopy the negative 2 in the back. Okay, with all the problems that have a number right here that is not 1, you have to get 4 different terms. Split the front 2 from the back 2 with parentheses. This method, what I do from right here on, is also how you would factor number 23 if you were stuck on 23. Okay, so when you have 4 terms and you're trying to factor, split the first 2 factors from the back 2 factors with parentheses. Take out or divide by your greatest common factor. So in the first set, you can divide them both by 5. They also both have an x. So if I divide 5x squared by 5x, I'm going to get x. In other words, 5x times x makes 5x squared. If I divide the negative 10x by 5x, here I can write it like this if you want to see it like that, I get negative 2 or minus 2. Okay, what's left over here will always look exactly the same as what you were left with when you factored that first factor. Seeing that this already is x minus 2 and I don't want to change it, if I divide them both by 1 or I factor out a 1, it won't change that. All right, now the two parts that look like they're separate that you divided out come together for one of your factors, and the part that's repeated that you see there is your other factor. So since on 27 and 28 it says to solve it, you needed to factor before you could solve. Solving means what values of x would make this 0. So here again, x minus 2 equals 0. X must be 2 in order to make this equal to 0. All right, so that's one of my solutions. My other solution, what value of x would make this equal to 0? I still see that in there. So my two solutions, sorry, I keep having issues. My two solutions are negative 1/5 and 2. All right, you can still email me. We can open a shared Google Doc if anyone wants to do that. I am open to any suggestions for how to best communicate to each other. But those would be my two solutions for this example that's similar to 27 and 28. All right, give it a shot.